Hello everyone, welcome to Exergic. I hope your GATE 2022 went well. In this video, we are going to discuss some questions from set 1 forenoon session of GATE Mechanical in a systematic, detailed and accurate manner. There are a lot more questions that I wanted to cover. We will be covering around 18, 19, 20 questions in this. There are even a lot more questions that I wanted to cover, but I didn't like to explain a wrong question to you, because if any data changes in the question, the solution totally changes, right? Obviously answer also changes. So the way to explain a question absolutely depends upon the accuracy of the question. Only the question which we could firmly verify, those are the questions here. Obviously, when the questions are memory based, there is always chances of error in the question. What students have told us, that could have some errors, so based upon that there can be slight variation here and there in the answer. Obviously answer can also change, but concept as such is not going to change. So we have ensured that whatever question we discussed, at least those are well verified questions. There are 2 points in this whole video that you must know even before you start the video. First is that if you don't find your question in this which you badly wanted to know from me, there can be a question which you badly wanted that, sir, you have to cover this, I'm not able to get it or I'm not able to understand it, feel free to comment. Even after this, I'm free and I think I'm open to make even more questions, even more solutions from set 1. Point number 2, with every question that I discuss, I have given a difficulty score to that question, a difficulty score, DS, to that question. There are 3 DS that I have given, 1, 2 and 3. Difficulty score of 1 means question is very easy, 2 means it is moderate, 3 means it is difficult. In some cases I have also defined 1.5 and 2.5, depends upon the question, but please check what difficulty level of question you were able to solve, or you might not be able to solve, you were not able to solve. So given these 2 points, let's not waste even more time. I have tried to keep the videos finished and edited so that you don't have to waste 4 and 5 hours just to get 10 questions or 15 questions of solution. I have ensured that in the short duration of 1 or 1.5 hours, you will be able to cover good 17-20 questions systematically with accuracy. I wish you all the best. And now have a look at this question from Engineering Thermodynamics. It says that Clausius inequality is valid for which of these options? Okay, so Clausius inequality, right now I am assuming that it is talking about Clausius inequality expression, the complete expression. Why am I saying that? Because in this inequality, this is the Clausius inequality complete expression, there are 2 cases. One case where there will be inequality, this less than equal to sign, and one case where there will be equality, right? So I am assuming that the question is not talking about this specific case. Even if it mentions, there is no relevant option for that, but right now I am making the confident assumption that question is talking about this entire expression, because this entire expression is called as Clausius inequality expression, right? So we know that when cycle, because if you look at option A, B, C, D, A, B and C, D options, they are very similar to each other, right? Any process, any cycle, reversible process, reversible cycle. So the key difference between options A, B and C, D is process versus cycle, process versus cycle. And we already know, we have already covered that Clausius inequality is used for cycles, right? We use it to determine the reversibility or irreversibility of a heat engine. Heat engine runs on cyclic process, right? So Clausius inequality is, and again you can look at the symbol here, which is a cyclic integral, right? This symbol is the symbol of integral, which can be used for any process, but this is the symbol of cyclic integral, which is used for a cycle, right? So clearly option A and B are incorrect. Coming to option C and D, as we already know that this will become less than 0 if it is for an irreversible cycle, and it becomes equal to 0 if it is for a reversible cycle, correct? So definitely D is true, but it is partially true. Clausius inequality is valid for reversible cycle, definitely, but option C is a better option because it is valid for irreversible cycle as well, which is covered in any cycle C, correct? Now, this question, I am sure it was a MCQ question, right? If it was MSQ, then option D could also have been correct, but since it is a MCQ question, I suppose, please note, these are memory based, questions are memory based, options are memory based. So if this is an MCQ question, definitely option C is present and this is the answer for this question. Okay. The next question from 80, thermodynamics. In a process, initial pressure of the gas is 110 kilopascal and volume is 5 meter cube. It follows this expression, right? PV to the power 1.2 is equal to constant. It follows this equation while going through a process. If gas is compressed to 2.5 meter cube, initial volume was 5 and it has been halved. Find the work done. Now, this is a very easy question, very direct question. You can clearly read and understand what is going on in the question. And here, rather than mentioning you about isothermal process, adiabatic process, the question has given you this expression, right? So, it's a polytropic process. The value of N is 1.2, right? So, you can very easily solve this question. P1 value 110 kilopascal. Be careful about the units because many times when the question is very easy, students get excited and they do silly mistakes, unit mistakes, right? Initial volume was 5 meter cube, final volume 2.5 meter cube. Since this is the expression which is going to be followed for the process, so P1 V1 to the power 1.2 is equal to P2 V2 to the power 1.2. P1 is known, V1 is known, V2 is known, P2 is the only unknown. Put all the values and solve it, you will get this value of P2 again in kilopascal. It's 252.7136 kilopascal. Logical also, pressure must increase, right? Because volume is decreasing, you are compressing it. We can see that pressure has significantly increased. Coming to find out the work, we can directly use the expression of work for polytropic process P1 V1 minus P2 V2 divided by N minus 1. N is 1.2 here, as we can see, this exponent 1.2. P1, V1, P2, V2, all values are known. Please note P1 values that we have here are in kilopascal. So whatever calculation you are going to do, you will get the answer in kilojoule, correct? So putting all the values and simplifying, you will get work done as minus 408.92 kilojoule. And this is where question gets slightly tricky because it's a memory based question. So exact, you can see even units is not written here, right? It is submitted to us by students. So maybe the question was asking you the unit in joule, maybe kilojoule. Accordingly, the answer will be converted. But the more important point is that whether it asked you to find out the magnitude of work or you have to put the work with sign. And we have already covered this so many times in almost all the courses, right? That if the language, gives you an idea that yes, it is compression, that find out how much is the compression work. If question mentioned that's the compression work, then the answer will be positive. Or if it says that find the work done on the system, so it has already mentioned that work is done on the system, it has already mentioned, so then you don't need to put a minus sign, right? So there are more such conditions and situations, but based upon the language of the question, two cases I told you, if it clearly mentions find the work done on the system, then it knows that it is work done on the system. Just tell the magnitude, because minus sign ultimately tells you that work is done on the system. So if question mentions already, or if question mentions that take it as compressible, find out the compression work, then you only have to bother about the magnitude, right? So again, in the lack of actual question right now, I have told you all the scenarios, all the possible cases. Now recall what was there in the actual question in your case, and did you check this point before putting the value or not? And if nothing is mentioned here, then definitely putting the answer with minus sign makes sense. If it comes to rate the difficulty score of this question, then I think the difficulty score of this question is again, it's 1, or for some students, given the 2-3 silly mistakes possible, it is somewhere between 1 and 2. It is somewhere between 1 and 2. Let's say difficulty score for this is 1.5. Okay. Now have a look at this question from fluid mechanics, specifically fluid kinematics, that in a flow, stream function is given by kx cube multiplied by y, where the value of k is equal to 1. and you have to find out this. What is this? Acceleration vector mod. It means magnitude of acceleration vector. Whenever we put mod across a vector, it means we have to find out its magnitude. When? Where? At 1, 1. What does that mean? Since, as you can see from the variables, we have only x and y variables, right? So it's a two-dimensional flow that we are talking about, and 1, 1 in such a two-dimensional flow means at x is equal to 1 and y is equal to 1. Basically, these are the values of x and y, right? So in order to start the process, what can we do to find out the acceleration magnitude? Firstly, you need to remember that it's a vector. Acceleration is a vector. It has the components along x direction and y direction. And whenever you have such a situation, to find out the magnitude of vector, you need to use this expression, root ax square plus root ay square, correct? This is used for any vector, right? Acceleration being one of that. Now, to find this out, we need to find out the value of ax and ay first. And if you recall from the expression that we have covered in fluid kinematics, you need the expression and values of u and v to find out the value of ax and ay. And in finding out the value of u and v, this stream function is going to help you. This is how you need to, build the solution in your mind. You have to move backwards, because finding out acceleration directly from stream function may not come to your mind directly, right? You need to build your case, build your solution coming from the last step to the first step, right? So to find out acceleration, you need the expression of velocities v as u as well as v, right? Velocity along x and y component both. And in that, this expression can help you, because we know that its differential with respect to x and y gives us the values of u and v, right? One with a plus sign, other with a minus sign, as we have done here, right? This is the value, this is the expression of psi given to us. We know this expression, right? We know that differential of psi with respect to x gives us v, and its differential with respect to y gives us minus u. So this is what it is, minus sign is here, this is u, right? If you differentiate that with respect to y, kx cube is what you are going to get with a minus sign, because minus sign is there in the expression relating stream function with u component of velocity, x component of velocity. Similarly, this expression again well known between v component and stream function, and where you have to differentiate psi with respect to x, considering others as constant. So k and y as constant will be coming. Differentiation of x cube is 3x square. So 3x square. This is what you have got for v. Now, since you have got the values of u and v, don't do the mistake of putting the values of x and y and k here, because you need to find out acceleration. And we know that with change of x and y, u and v are going to change, and we are interested in the change. We don't want the value of u and v at 1, 1. We don't want the value of u and v at 1, 1. Rather, we know we need the value of acceleration at 1, 1. So, to find out acceleration, you need the change of values. You need the differential of u and v. So, by any mistake, don't just put the value of x and y here. You will not reach anywhere if you do that. So, coming to these expressions of ax and ay, these are usual, well-known expressions, correct? Many students sometimes confuse in these expressions, but there's a simple way to verify whenever you get confused, that when you have to find out acceleration along x component, then the differential will be of x component of velocity only. Means if it is ax, differential will be of x component of velocity, which is del u. Similarly, when it is ay, differential will be of y component of velocity, which is del v. It's just a way to ensure that you have not written anything incorrectly, because u, x and y, only these three terms are there on the right hand side, and there are different ways in which they are presented, right? We know the concept behind it, obviously, but this is just one way to quickly verify whenever you are confused, because I have seen many students, do mistake in writing this expression. Again, it's not a very complex expression, it's comparatively simpler, but it's a possible mistake. Now, you have to differentiate del u with respect to x, u with respect to x, u with respect to y, and then put the values of u and y. If you go back and check the expression, this is the expression of u, there is no y term here, there is no y, there is y to the power 0, there is no y, right? So here if you differentiate that with respect to y, you will get 0. So here the differentiation of u with respect to y is going to be 0, so only this part you have to differentiate. right? So here, if you put the value of u minus kx cube, you differentiate that with respect to x, multiply 3k square x to the power 5, you will get. Similarly here, put the value of u, put the value of v, differentiate v with respect to x and v with respect to y. That differentiation I have done there. And then just multiply them together, simplify, ultimately 3k square x to the power 4y. This is the value that you will get for ay. And now it's very simple. Now you have to put the value of x as 1 and y also as 1, because question asked you to find out acceleration at 1, 1. Just put the values here. Now when you put the value of x and y as 1, 1, this is going to become 3k square and this is going to become 3k square as well, because both x and y are 1. And now to find out the total acceleration, we will do ax square plus ay square whole under root this, right? Again, one more good simplification. The value of k was equal to 1. So basically it is root of 3 square plus 3 square. So it is 2 multiplied by 3 square root. 3 will go out and it will be 3 root 2. Value of root 2 is 1.414. You just put the value and you are going to get the answer. So this question, I won't call this question a difficult question, right? There was no special trick or special method which was to be used or special concept to be used. But yes, I feel many students will not be able to see the path from here to here. They will be able to see the path from here to there, from acceleration to stream function. But from stream function to acceleration, some students may not feel it that easy. So when it comes to give the difficulty score of this question, I wanted to give it 1, but I will give it 2. So difficulty score of 2 is there for this question. If you recall GATE 2021, there was a slightly tricky question in thin cylinders from strength of materials, right? The thin cylinder was not having closed ends, the ends were open, right? Question from GATE 2021. And in GATE 2022 also, slightly tricky question came. I am not calling this question as difficult. It is not difficult. In fact, many students would have solved it correctly and easily. But I think a good 20, 30, 40% students might have struggled in this question slightly. At least those who don't have a clear basics of what is going on in thin cylinders. So if you look at this question, a thin cylinder is of radius small r and thickness t. If its perimeter is increased by 0.1%, this is a thin cylinder, right? And when we talk about the perimeter of thin cylinder, we mean the circumference, the perimeter, right? The boundary. So it basically means the circumference. Many students, I feel, would have got confused in perimeter. They would not have concluded what exactly question has given us, because it is in a way the only data given to you in this question. Not only Poisson ratio is also there, but only big data given to you here is perimeter is increased by 0.1%. So what exactly is that? Many students would have struggled there. Anyway, as I told you, that is telling you how much is the percentage increase in the circumference, right? Circumference is pi d. So when we have been given percentage increase of circumference, then this is what we have been given, correct? Del c by c is the fractional increase, multiplied by 100 is percentage increase. And we know that percentage, when we talk about percentage change, fractional change, then for this expression, since pi is a constant, the fractional change or the percentage change of circumference will be same as the percentage change of diameter. I think we have discussed this so many times in strength of materials, even in the starting part where we discuss about how the volumetric strain is related to individual strain. There also I talked about it, and even in the case of thin cylinder we discussed this. So here this change, percentage increase, what is given to you is actually the percentage increase of diameter which is given to you. Why diameter will increase? Why is there a change? Because it's a pressure vessel. Inside there is pressure. Gas is exerting, fluid is exerting pressure inside, due to which the dimensions change. The diameter increase, right? Question is asking you calculate percentage change in thickness if Poisson ratio is given as 1 by 3. Again, be very careful. It is asking you percentage change. Changes can be positive or negative. Means, obviously in real life also changes can be good or bad. But here also, in calculations also, as we have discussed, that change means with the sign you have to put the answer. It can increase or it can decrease. Got it? So here, what is your guess? What do you think would have happened with the thickness? What do you think? Whether the answer is going to be positive or negative? Meanwhile, if this was not question from your set, or if you are maybe gate 23 aspirant looking at this, try to think. At least sign you can guess. Anyway, so if we go ahead and if we try to solve this question, now this is an image from my lecture of thin cylinders where I had drawn this image. So here you can see that I have shown this element enlarged, an element on the wall of the surface in an enlarged view where you can clearly see the circumferential hoop stress and the longitudinal stress which is acting, right? Sigma C and sigma L. Longitudinal acts along the longitudinal direction obviously, and sigma C along circumference. This diagram is important to solve this question, very important, because here you have been given, you can say, the percentage change or fractional change of diameter, and question is asking you this multiplied by 100. What is question asking you? Percentage change in thickness. What is that? Fractional change multiplied by 100. This is what question is asking you, right? So you need to write the expression of strain along the diameter and strain along the thickness. So you need to analyze this element here and see what stresses are going to strain them, because Poisson ratio is also given to you, right? So if you write down that expression, so let P be the pressure inside the cylinder, internal pressure is, let's say, P. So if I write the expression of strain along the diameter, so it's going to be the diameter, this entire diameter, directly strained by the circumferential stress. So sigma C divided by E, this is sigma C, P d by 2T, correct, divided by E. So this is your strain, direct strain from sigma C, and Poisson effect are also to be considered. Poisson ratio was given to you in the question. So minus mu times of the Poisson strain that you have, which is sigma L divided by E. Sigma L is P d by 4T divided by E, correct? So this is the expression for del D by D. Similarly, if you want to write the expression for del T by T, again you have to analyze this. And now we are only looking at this dimension. Why? Because this is the thickness. If question gave you something, some value of internal pressure, then it could have been considered as a direct stress or direct pressure trying to change the dimension. Although there are more complications than that. I've already told you that anyway is negligible and we don't take that in many calculations. Here also question did not give you any value of internal pressure. So to change this dimension, there is no direct considerable effect, right? There is internal pressure, but that's not considerable, that's small, we already know that, and especially here it has not been given to you. So there are only two stresses, sigma C and sigma L, who are working here. But if you notice, both of them are going to have only the Poisson effect on the thickness. The sigma C, that is also going to shrink the thickness. This is the tensile stress applied, it will shrink all other dimensions, it will shrink the thickness. Sigma L also, it is going to, it's tensile, so this dimension it will try to elongate, but all other dimension it will try to shrink using Poisson effect. So thickness will also try to shrink. So thickness is going to get reduced by both sigma C and sigma L. How? By not direct stress, but by Poisson stresses, Poisson effect. So minus mu, and then you have to write the expression of strain due to hoop stress and then longitudinal stress. So minus mu, correct? There's a plus sign here because minus has come out as common. Both of them are trying to shrink this dimension, reduce this dimension. And sigma C is Pd by 2T, sigma L is Pd by 4T, correct? So we have reached up to this point where at least we have written the two expressions. One is given to us, in a way this value is given and this value is required. Now when you look at the question, it is asking you this value, but it has not given you P, it has not given you D, it has not given you E, and T also I think it's not given, right? Nothing is given basically in the question. None of these values are given to you, right? Now if you think that I will put this value as del d by d is multiplied by 100 is given to you, so this expression's value you can find out, and then I will try to find out the value of PDE and then put it here individually. You cannot do that. Individually you cannot find out the values. There are too many unknowns and too few equations, right? And a given equation is only one, right? So you have to collectively find out the value, because you can see that P d by TE, this term is common, right? Here also, PD by TE, PD by TE, PD by TE, PD by TE. So entirely PD by TE you can call it to be X. PD by TE you can call it to be X. So you will get X by 2 minus mu X by 4. That value is known to you. Here, if this is X, so X by 2 minus mu X by 4. That value is known to you. Mu is also known to you. So you can find out X, means you can find out PD by TE. Means here also if you take out PD by TE as common, if you take out PD by TE as common, let's say it is X, you will be having 1 by 2 plus 1 by 4 multiplied by mu. Right or not? So in this manner, if you put the values, find out X and put it there, you can solve it. Other way would be to divide them. If you take their ratio, if you just divide them, then obviously this process becomes slightly easier to solve, because it will get directly cancelled. PD by TE cancel. Why? Because it can come out as common from numerator as well as from denominator. So you will have only 1 by 2 minus mu 1 by 4 is equal to minus mu 1 by 2 plus 1 by 4. Right? And this is equal to del d by d divided by whole divided by del t by t. Basically, it's the ratio of circumferential or diametral strain to the strain of thickness, fractional change of thickness, correct? So here, after putting all the values, because mu also has been given to you as 1 by 3, so it will become 1 by 12. This will be 1 by 3 here, right? So if you put all the values and simplify, this ratio will come out to be equal to this, and this will become 3, it will become minus 5 by 3, which is del d by del t. Del d by d divided by del t by t is equal to minus 5 by 3. You have to find out del t by t, which means you will bring that there, and it will minus 5 by 3 on going to left hand side will become minus 3 by 5 del d by d, right or not? And now here del d by d is in percentage, it is known to you. So if you multiply that with 100, this will also be multiplied by 100. So if you directly put the percentage change here, you are going to get the percentage change of thickness. Now, one point to note here. The good thing is that if you look at the value here, it has given you increase by 0.1%, increase by 0.1, correct? And it is asking you the change. In the answer, you have to put the value, you have to give the value with plus or minus sign, because it is change. So obviously, while putting the value also, you have to consider the sign plus or minus. Good thing is, question gave you increase, right? So even if you did not know this, you are going to put 0.1% only, you will get the right answer, because increase means plus. Anyway, if you don't put plus, it is a plus. No sign means positive sign. But somehow, hypothetically, if this was decrease, then the value that you had to put was with a minus sign, not with a plus sign, because change is required in the question. Anyway, here you have been given the increase. So here, if you put the value, you are going to put 0.1% in place of this, del d by d multiplied by 100, you will put 0.1, right? So if you do that, what you are going to get? Minus 3 by 5 multiplied by 0.1%, right? That will give you percentage change of thickness. So this becomes minus 0.06 as is written here also, minus 0.06%. Got it? So again, there are chances, I feel some of the students would have done mistake here, right? Where you have to take fractions and percentage, as many students are not comfortable in fractions and percentage. So I think 10, 15%, maybe 20% students would have done some mistake, right? In fraction and percentage, some sort of mistake here. Maybe some of them would have divided that with 100. They would have forgotten that on the left hand side also there is percentage. So we can directly put the percentage here. Right? These are some possible mistakes which students could have done. Anyway, in this question, even if those silly mistakes are not, you are not doing. Still, I consider this as a good question. Now, when it comes to difficulty score of this question, I think many students will find this difficult. I'll give it 3 difficulty score points. Please note that I'm trying to see this question. I always try to see questions from students' point of view. So from that perspective, I'm answering. Otherwise, I know that 5, 10, 15% students will find this question very easy, very doable. Just put the value, solve and get the answer. There's nothing difficult here. But many students would have struggled in understanding this perimeter part. There are chances of mistakes in fraction part. So I feel many and very less values are given to you in the question, right? So some of students might have got confused that where to start, what should be the first step. Considering all those points, I think it's a question of difficulty score 3. Now have a look at this question from welding manufacturing. And as I keep telling while teaching welding, that if you understand the process and process parameters, what is welding speed, what is its effect, what is filler, what is its role, what is melting efficiency, what is its importance. If you know all these things, no matter what type of question is given to you, with what variation, you will be able to solve it. And this is one of such question. Have a look at the question. In a welding process, following data was given. Voltage is given, current is given, welding speed is given, heat transfer efficiency, melting efficiency, filler rod diameter is given. The weld bed formed consists of 60% filler material and 40% base material. This diagram might not be given in the question, but I have anyway drawn it. So this part has 60% material coming from filler rod. You have a filler rod, right, which melts and has so many different benefits for the welding, right? We know its different advantages. So 60% of the material here is coming from filler rod and 40% is coming from the welding of the base material. Okay. Calculate the filler feed rate, because this filler needs to be fed to the weld bed. Why? Because it is continuously melting. It is continuously melting. It is getting away from the weld bed. Now, if this is the filler rod and this portion gets melted, it got away from the weld bed. You further need to insert it so that it can melt and contribute to the welding. So you need to continuously feed the filler. That feeding is also sometimes done automatically in advanced machines. It is automated or it is done manually, right? So here question is asking you, what should be the speed with which you have to feed the filler? Many students in the question of welding rely on formulae, and I always deny that. Whenever I teach this topic, I absolutely deny that learn this expression or learn that expression. I always tell, understand the process, what is going on the basis of that solve the question, because question can have variations. You cannot have formula for all the variation. You don't have to remember it for all the variations. So in this case, let us see what is happening here. Suppose if we try to find out the, let's start from the bottom again and let's start moving up. Calculate the filler feed rate, take specific melting energy at 10 joule per mm cube. Now, whatever filler is being melted is contributing 60% in the overall welding. So if I am observing the welding maybe for 5 minutes, 4 minutes, 1 minute, so in that duration, whatever welding has been done, that welding only 60% volume is contributed by the filler rod, right? So if total volume of weld is how much? Let me clear it, this part at least. The total volume of the bed is its area multiplied by the speed with which welding is occurring. Welding is occurring with the speed, right? Where you are moving this setup along the joint. So entire the area and velocity that you have, entire volume that you have deposited, 60% is coming from filler rod. How much is the rate of deposition of weld material? It is area multiplied by velocity. If you look at this, it is like a fluid being filled. In reality, we are not filling everything, but fluid being formed. So the rate with which it is being formed is area multiplied by the velocity of the welding, correct? The unit of this is going to be in mm cube per second, and 60% of this is coming from filler, right? So if you multiply 0.6 to this, you are going to get 0.6 AV will tell you that how much how much deposition rate is contributed by filler. That is what we have done here. This is telling you the contribution rate of filler, right? Per unit time, because this is area, let's say mm square, this is welding speed, mm per second. You multiply them, mm cube per second, deposition rate, correct, per unit time. If you look at the filler, any filler at any point of time, how much material is it supplying? It is supplying the material through its cross section, right? This is how the filler rods are, circular cross section, a filler rod, correct? So if I observed this for maybe 2 minutes, 3 minutes, so some length will get contributed, right? How much volume it has contributed? Pi d square by 4 multiplied by this length. But we are doing rate analysis, per unit time we are observing. We sat and we observed the process for 1 second, and in 1 second we saw how much filler contributed. That is equal to 0.6 of total rate. In 1 second. In 1 second, how much volume came? 60% came from filler. So here, pi d square by 4 will not be multiplied by the length of filler, because length will keep on increasing. You wait for 2 seconds, length is this much. You wait for another 2 seconds, length will get doubled. Wait for another 2 seconds, the length will get even more increased. So we are also observing it per unit time. In per unit time, how much it contributed? That is equal to 0.6 AB. That is why in place of length we have feed, which is the rate with which you are feeding it. So reaching this expression requires common sense. What is going on in the process? Once you have understood that and you have written this expression, things will be very easy for you. Diameter of filler is known to you. F is required, you need to find out. And this is not known to you. A multiplied by V you need to find out. Basically this is deposition rate. This is the deposition rate. You can write it as dr or any variable you can give it. And how do you find that? If you look at the question, you have been given a lot of things, right? You can use that to find out the deposition rate. How? If you look at the values given to you, voltage and current, they are the input electrical energy given to you. If you multiply them, we know that power is equal to V multiplied by I, right? So how much is the rate of electrical energy supplied? This will be coming in watt, which is joule per second. So how much is the rate of electrical energy being supplied? That you will find out by multiplying them. But we know that all that energy is not finally used to do the melting. There are different efficiencies or inefficiencies in the process. Heat transfer efficiency, melting efficiency, right? Those are also known to us 0.7, 0.6. So you need to multiply those efficiencies here to understand that ultimately how much heat is reaching as input for welding. And that energy is then going to melt, is going to do the melting. So this net energy that we have here in input is given by this expression Vi and then both the efficiencies which have been given to us. If you put the values 150, 20, 0.7, 0.6, you will get 1260 watt or 1260 joule per second. Coming to the final output of melting, output here is melting. Now if you compare the input and output here, input is given, as I told you, in the form of electrical energy with some efficiencies. So if you put the value V value, I value, both the efficiencies, multiply them, you will get 1260 watt or watt is joule per second, right? Now look at the output. Output means what output, melting output you are getting. So what melting you are performing ultimately? In 1 second, how much material you are melting is given by mm cube by second, which is given by Q, which is nothing but area multiplied by velocity, right? Already discussed deposition rate, cross-sectional area multiplied by velocity, just like we have discharge in fluid, right? Where we, find out how much is the volume flow rate passing through a cross-section. Similarly here, how much is the volume deposition rate of welding is given by area multiplied by welding speed, welding velocity here, which is mm cube per second. And to melt 1 mm cube, how much energy is required? That is given to you, specific energy. If you cancel both, joule per second, you will get here also, right? So this product here needs to be equated with 1260. If you do that, what will you achieve? You will be able to get the value of this AV, which is equal to Q multiplied by the specific energy, is equal to 1260. You do that, you will be able to find out AV. Basically, this is 10. This is 10, right? Specific melting energy is 10 joule per mm cube. So if this is 10 is equal to 1260, so AV is equal to 126, right? Now what you need to do, you just need to put this value of AV here, and F is the only unknown that you have to find out. D value is also given to you. Filler rod diameter, this D is also given to you. So just put the values here and ultimately given to you. We calculated, this is the only unknown, solve it. You will get this as your answer of this question. Again, the unit you need to be careful about. Here we have not been told any unit by the student, so we have not written it, but be careful, maybe unit was asked in centimeter per second possible. So ultimately you need to convert whatever answer you have got into suitable units. When it comes to rate the difficulty score of this question, I don't think it's a difficult question as such. If you have solved questions on welding, the only minor variation you can feel somewhere is just this filler rod and base material. Otherwise, everything should be known to you. So I'll rate this question from the student's point of view at around 2.5, right? Not exactly 3, but for many it's not 2 also. So 2.5. Now have a look at this question from Applied Thermodynamics, which I will consider a very easy and a doable question. I'm sure majority of you would have done this correctly. In an Otto cycle, following data was given. Displacement volume was given to you. Clearance volume was given, which is the minimum volume. Inlet pressure is given. Inlet temperature is given. Heat added at constant volume is given to you. CV value and gamma values are also given. This is 1.4, not 14. It's a error in typing. Gamma is 1.4. The maximum pressure in the cycle is how much? Whatever unit question gave you, accordingly you had to answer the question. So this is the cycle, the Otto cycle that we have drawn here. 1, 2, 3 and 4. This is same volume, V1, V4 are same, let's call that V1. V2, V3 are same, let's call that V2. P1, T1, known to you. Regarding volume, if you notice, you have been given clearance volume, which is the minimum volume. If I just clear it once. So this clearance volume is this V2, minimum volume, correct? This is V2. And you have been given displacement volume. Displacement volume, as we know, is this volume, V1 minus V2. Swept volume, the volume which it sweeps, it displaces through that volume. So V1 is going to be equal to, V1 will be equal to V2, which is the minimum volume, clearance volume, plus displacement volume of 250. So this one is going to be 285.7. V1 is going to be 285.7, right? As you can see here, V2 known, and this expression PV to the power gamma is equal to constant. Definitely this and the variation of this we are going to use in this process. Initially, question is asking us, question has given us the inlet pressure and inlet temperature, and it has also, these are the three process temperature and process properties which are known to us. The inlet pressure at 1, here how much is the pressure, how much is the temperature, and then it mentioned how much is heat added at constant volume. This is the point, right? 2 to 3, where you add the heat at constant volume, right? This is known to you. Firstly, since we have been given that heat added at constant volume means from 2 to 3 is 800 kilojoule per kg, and this is the expression for that. At constant volume, heat added is CV T3 minus T2, CV T3 minus T2. So this expression definitely we have to use. But in this, CV is also known in this expression. So T3 and T2 are not known to us. If you look at the given values, we have been given only the inlet temperature T1. This is the only temperature that has been given to us. And obviously this expression needs to be used. This is a value which has been given to you. So T3 and T2 are anyway required. If you look at this graph, this is a data which is given to you. Question is asking you the maximum pressure in the cycle, means pressure or the property of this point. You have been given properties of this point, temperature, pressure, whatever, and question is asking you one property of this point, point number 3. This point number 2 is definitely going to play an important role there in linking 1 to 2, then 2 to 3. As well as we can see that here also property of 2 is required, temperature at 2 is required, right? So right now let us focus on getting the properties of point number 2, because we are here in a way, we have been given the property, one property of here, rather I think two properties, no? Two properties, pressure, temperature, both. This is given to us, this is what we have to reach, and 2 is clearly a better path because we anyway require to find out the temperature at 2 to use in this expression, right? Whenever you had such questions of graph where so many values are there, every point has 2-3 different values, in total you have to deal with 9-10 different values. So questions look easy and they are easy, but so many values confuse students that what path should they choose, from where to start, because there are n number of things that they can do. You have different equations to apply here, you can use ideal gas equations here, so many things you can do. So it's always best to have a clear path in your mind from where you are starting, from where you have to end, you have to reach for your answer, and what point, what path, what property can help you in that. Definitely properties of point 2 are extremely crucial here. They are not only linking point 1 and 3, but it is also required clearly here in this expression which we have to use. It's a given expression to us, right? So to find out the properties at 2, these are the two equations that we have used. This is nothing but the relationship between the P and V, pressure and volume. PV to the power gamma is equal to constant, right? Between 1 and 2, we can apply this equation. PV to the power gamma is equal to constant for the Otto cycle, and which means P1 V1 to the power gamma is equal to P2 V2 to the power gamma, right? P1 is known, V1 is known, V2 is known. Gamma is 1.4 given in the question. P2 is the only unknown which you can solve from this question. Similarly, if you apply again the temperature equation between point 1 and 2, so T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. T1 is known to you, V1 is known, V2 is known, T2 is the only unknown, right? So T2 is equal to T1, V1, which is this, divided by V2, which is this, to the power gamma minus 1. Solve it, you will get the value of T2 that we have got. So T1, T2 value, P2 value, both values we have got at point 2. And now if you look at this equation, CV was known to us. Again, careful about the units. That is also kilojoule. This is also kilojoule. Kilojoule per kg. You have to be careful about the units all the time. So from you putting all the values and solving, T3 value we have got. What next? We have to find out, if you look at this graph, at this point we know the temperature, right? At this point we know the temperature and pressure both. And we know that this process is a constant volume process. For constant volume process, if we apply the ideal gas equation, this is constant, these are constant, ratio of P by T becomes constant. P by T is equal to Mr divided by V. M, R, V all are constant for this process, so P by T becomes a constant. Here P and T are known to us, here T is known, P is unknown, and P is the value that you have to find out in the question. So let us do one thing, let us simply put the values in the constant volume expression, this expression, P by T is a constant. So P2 by T2 is equal to P3 by T3, P3 value is equal to P2 multiplied by T3 by T2. So this is the value of P2. P2 we calculated in kilopascal. T2 value is this which we put here, T3 we calculated, put it, solve it, and you will get the answer in kilopascal. This is a very easy, very doable question. But as I told you, if student is not clear on what has been given, where to reach, he may end up wasting time in this question. It is, I am explaining to you, that's why I have to show each and every step. But as a student also, some of you may cross 3, 4, 5 minutes wasting time in trying different things. So it's important, the analysis that I told you, that what you have been given, where you have to reach, which point and what values will help you in reaching there. All this analysis, if you do for 15, 20, 30 seconds in your mind before starting the question, it can actually save your time in overall solution of the question. When it comes to rate the difficulty level of this question, again, it's not a very difficult question in my opinion. I will give this a difficulty score of 2. Okay. Have a look at this question from manufacturing. Which of the following additive manufacturing S with a bracket means question might be referring to one or more than one can be used as a wire, can use a wire as feedstock material, right? You feed the stock, you feed the material. So which of them uses a wire as a material, as a source through which you can feed the material? Now, if we talk about this type of question, then many students have said that it was MCQ. But I feel it can be MSQ as well because of this bracket, and S means more than one is a possibility, and actually there is a possibility of more than one in a question. If I talk about the options, directed energy deposition process and stereolithography and selective laser sintering and fused deposition modeling, out of these four, the most obvious and clear is option C. Rather, in additive manufacturing lecture number 2 or 3 at 11 minutes, we have discussed it, not at a minute, we have discussed it for 5 minutes just about the wire and the use of spool, right? So I'm sure that you have picked C at least, because even this diagram, again this is the diagram from the course only, where the wire were clearly shown, it was discussed, the spool was shown, even in fact entire animation was shown to you. So I'm sure that option C is clear to everyone that yes, this is the correct one. If this was MCQ, this is the most appropriate option to tick. But if this was MSQ, it opens the possibility in directed energy deposition process also, which use different ways to deposit the material. Wire is also one of the ways. So that is why, let's see what type of question this is and whether this question gets debatable or not. But if this is an MCQ question, option C is the most correct one. Have a look at this question, a question which I feel was a good question as compared to the other questions in the set, and I think many students would have stuck somewhere in this question or would have slightly struggled in the question. In the following figure, what will be the direction and magnitude of force on the pin from the slot on the application of load P? So this is the load P which is being applied here. You can see that there is a slot here, right? And inside which obviously this bent beam is there, and there's a pin, you can say. 4A is this length, A is this length. Question is asking you the direction and magnitude of force on the pin here from the slot. This is the slot. This is the slot, and inside this slot there is this pin. When it comes to direction, it's definitely going to be like this. I don't know whether this was NAD question or MCQ. I think it should be MCQ question, right? Because it is asking direction also. So if the direction was asked in the question, it's going to be either in this direction or in this direction. We already know, we have already discussed that whenever there's contact between two surfaces, then force is transmitted, force acts along the common normal. This is the common normal, right, of the spin and of the slot. So force is going to act along this surface only. There cannot be any component in the horizontal direction. Point number 1. Point number 2, when it comes to magnitude, it's interesting in this question because there are different possibilities, two possibilities. One, that there was a hinge here. This is a possibility which will change the answer. Or two, that the beam was fixed like this. If it was hinged here, then it would have been very simple. Because if you draw the free body diagram, you cannot have moment at the end A. This is end A, let's say, this is B, this is C. So if A is hinged, you cannot have a moment at A, right? So in the free body diagram of ABC, there will not be any moment at A. Simply about A, you can apply the balance of moment. P multiplied by A should be equal to R multiplied by 4A, right? If I have drawn this free body diagram, this is P. Let us say this is R, and if this was pin, then here there is no moment. Then about this point, if you take the moment, it's going to be R multiplied by 4A. In this direction, R will be acting in the downward direction in that case. So clockwise, R multiplied by 4A is equal to counterclockwise P multiplied by A. That will give you R. But if this is not the case and this is a fixed, at this end it is fixed, then obviously some moment is going to act there, moment is going to be present there. So directly we cannot do this analysis because that is an unknown fixing moment that will be acting there, right? So in order to find out the unknown value of reaction, whatever be the direction, we need to look into the proper methods of solving this. We are going to choose the strain energy method here to save time in the discussion, because look, it's very it's very tempting for me. I want to discuss all this question in great detail, right? 30 minutes, 40 minutes I can talk about the different variations and all those things, but I have to balance two things here. I have to tell you these things in time, as well as I have to explain you the concepts. Now in this free body diagram we have shown the reaction R here, right? And we need to find out the value of this unknown reaction, correct? Let us apply the strain energy concepts for that. Here in this whole beam, the total strain energy in this section is due to load P and load R, right? So m square dy divided by 2EI from this section, from 0 to A or from C to B, that is calculated here. Then in this section AB, we are going to calculate the strain energy using whatever moment is going to act there, right? In this section AB, what will be the moment acting? This P multiplied by A is going to be a fixed moment acting at B, because P is fixed, A is fixed, right? And that PA and this R, which will be shifted here in AB, both of them are going to interact, and at any section if you check the moment, what moment will you get? A fixed moment due to PA, which is going to act in this direction, counterclockwise direction, but R multiplied by this distance is going to be a clockwise effect. So both of them are going to be subtracted. Let's say X is this distance. So at any section, PA multiplied by RX is the net moment at any section. So you see that we have calculated two different strain energies for this section and this section using two different values of moment. Again, something that we do a lot of times. Even if I tell you that some simpler variation of this question, GATE has already asked simpler variations of this question, right, where load is acting in different directions, correct? So this is a variation of that only. So I'm sure that using strain energy, many of you would have done it, but some of you would have definitely struggled if you missed to see that this end is fixed and not hinged. Now here, if you open the bracket, integrate, this is the expression that you are going to get. Let's move forward. So if you integrate it and put the values, 0 to 4a, this is the long expression that you will get. What next? Why have we done this? What can we do by this? Because if you look at this free body diagram, then in this direction, in the vertical direction, how much is the displacement? 0. Because here it is a pin in a slot. It cannot get displaced in the vertical direction, in the direction of R. So the total strain energy with respect to R should be equal to 0. Total strain energy of A, B and C with respect to R should be equal to 0. That is what we are going to do here. Total strain energy with respect to R will differentiate and put it equal to 0. So this expression, when differentiated and when you put that equal to 0, this is how you are going to solve it, and ultimately the value of R you will get as 3P divided by 8. So if the question has fixed end at A, this is how this question can be solved. When it comes to giving the difficulty score to this question, I think it's somewhere between 2 and 3, 2.5, but since many students might not be able to solve it in exam pressure, I think, given the slight change of pin and slot and all these things confuse many aspirants, right? They forget that essentially it is the same question that they have been solving, the same question GATE has asked so many times, right? But just slight variation and students confuse. So I will put it somewhere between 2 and 3, but let's keep it 3 for now. Have a look at this question from Inventory Control Industrial Engineering. Which of the following is not an inventory, right? Answer is very obvious, but I will still tell you the way in which you can reach to the answer even if you don't know the answer. Let's start from option D, in-hand inventory. Name itself suggests it's an inventory. How it cannot be an inventory, right? So definitely this is an inventory. You have to tell which is not an inventory, right? You have to tell which is not an inventory. So this is an inventory. It cannot be the correct answer. Finished goods are kept in an inventory. Again, you can use your common sense even if you don't know the answer, that obviously finished goods are kept in inventory. You cannot just make the product and the loading truck is waiting for you. It does not work like that, right? There's a specific transport schedule. Only then loading truck is there. Otherwise, whatever you make, you have to keep in inventory. Same is for raw material. Raw material is not going to come every time you are doing the production process. It comes as a schedule. You have to stock it and then use it. That's what inventory is. So I'm sure anyone who has idea of what is inventory should know that raw materials and finished products are kept in inventory, right? So A cannot be true, this cannot be true. Only machine is the option, even though it should be clear to you that machines are not kept in inventory. They are huge, they are costly, and you don't require new machine every day. A good reliable machine can run for months and years with right maintenance, right? So you don't maintain the inventory for machines. So even if you know the concept of machines and inventory, you should get to the answer B. Even if you don't know it, then using the elimination of the option, you can reach option B. Got it? In terms of difficulty score, I will rate this question as 1. Okay? Have a look at this question from Theory of Machines. If this question needs explanation, then I think you have not prepared at all, right? It's such a question of theory of machine that in every test you would have seen similar or better question. We have discussed and solved so many questions on this, so I think this is a pretty basic question. If I go ahead and explain this question, it will be an insult of your preparation, right? So I'm just going to show you the solution here. You can go through it, and I think that if you have prepared, you would have done it. I think 99% students would have solved this question correctly. So you can go through the solution which I have done. And if you have any question or confusion here, definitely you can ask in the comments. But I don't think there should be any confusion or question here. If I want, I can explain this question for 20 to 30 minutes. I can explain the whole process. There are more than one way to solve this question. There are more than one ways. You can go by the tabular method. You can go by the analytical method. Even other than these two, this simple gear train can be solved by one more method, logical method. So there are 3 ways to solve this question, which we already know. I'm not going to cover it. Go through the solution. In case you have any question, you can ask me in the comments. Okay? Have a look at this question from Vibrations, Theory of Machines. This question is an extremely easy question if you have gone through the course, if you have watched all the solved examples. Rather, I will consider this as a rather easy question. I know many students might think of this question as slightly tricky, but definitely you have not practiced enough questions if you think this is a difficult or tricky question. This question is just like any question of compound pendulum, as simple as that. Have a look at this question. A rigid uniform disk of outer radius r and inner radius small r. This is a disk, rigid uniform disk, outer radius r and inner radius small r. It is hinged from the inner circle. This is important, as shown in the figure. You can see that inner circle is hinge point. It is hinged about the inner circle at a distance of small r from the center. The relationship between small r and capital R is given to you, right? 2r square is equal to capital R square, or capital R is root 2 times of small r, 1.41 times of small r. G is the acceleration due to gravity, undoubtedly. If the time period of oscillation is given by this expression, find the value of beta. Actually, it's just asking you to find out the time period of oscillation for this. Once you calculate that, everything else other than pi root r by g is going to be your answer, is going to be beta. Before we do that, let us see how are we going to displace this, how are we going to oscillate this. As we already know, this is hinged about this point. What is the constraint? That you cannot displace give any x or y displacement about the hinge point, but definitely you can oscillate, rotate it about that point. So we'll give just a small displacement to this about this center, about this hinged point. What two forces are going to act? What two moments are going to act? One is going to be inertial moment, other is going to be weight. Because right now in this situation, where is going to be the center of gravity? Here, right outside the body. Right? Center of gravity can lie outside the body. It is here at the center. When you displace it, this point also gets displaced. The center of gravity also gets displaced. So it applies a moment about this point O. I have thoroughly told this using different cases. And I think similar case is already covered in course in slightly different form. It was not a circle. It was straight bar in a circular curved surface. Right? So we clearly know that in this case, weight is definitely going to come in the expression of oscillation, because it is going to actively involve in the oscillation. When it is on the right side, it will try to rotate on that side. When it will shift on the left side, it will actively rotate on the right side. So weight is not getting statically balanced. It is actively trying to oscillate, once clockwise, next counterclockwise. So weight definitely is going to come as a factor in the equation, in its equation. But before that, let's find out the equation of moment of inertia for the inertial term. When we write its equation, two factors are going to come. One factor for inertial component, one for weight component, and that we will equate to 0 in its equilibrium equation. To find out the weight term, I just already briefed you that yes, it is going to be there. It is going to be there. Right? Reason already briefly explained here. In detail, we have discussed it so many times. I think we have solved enough 2-3 hours of question only based upon these concepts, right? So coming to one point where mistake is possible, which is in calculating moment of inertia. Because to calculate the inertial component, I need the moment of inertia of this motion, which is about point O. We know the expression of I about C, right? This we already know. Standard equation. But using the parallel axis theorem, we need to shift it from C to O. And that is a possible variation in the question, that maybe the question, rather than fixing at inner radius, it can fix it at the outer radius like this. It is hanging like that. Or maybe it can hinge it at a certain point on the disc, maybe at the center point. So that distance will change. In applying the parallel axis theorem, this distance will change, mr square, that will change. This point, this distance in parallel axis theorem is the distance between this point and the point where you have to shift it. Here, you have to shift it at the inner circle, which is at a distance of r, inner circle radius. If this point is different, then definitely this value of r will change here. It will not be mr square. R will be replaced by capital R or maybe some other value of R between inner and outer values. So IC is known to us, standard formula m small r square plus capital R square by 2 plus mr square. To save the time, we have done that already. You simplify, solve it. This is the value of I about C that you are going to get. And now let us put this value in the equilibrium equation of this vibration. So this is the equilibrium equation of this vibration. I theta double dot, step 1, which considers the inertial component plus weight component. This is discussed so many times, this component, the significance of r theta. Even I think on the YouTube channel, it was the question, I uploaded a question where I told the significance of r theta in detail, right? So when it is getting shifted by a small distance, this distance you need to find out, which is equal to r theta. There are two ways to find this distance, either by triangle property or by the circle property, by considering this to be a part of bigger circle, a small arc. Using both the cases, this length will come out to be r theta. This is r, this angle is theta. This is theta, this is r, and this is r theta. If I explain it further, I am sure you will start getting bored from it, because this has been discussed so many times. Using basic theta is equal to L by R also, the property of circle also, you can reach at this conclusion, or you can use sine theta is almost equal to theta for smaller values of theta. Using both the properties, we can reach here. I am not going to invest more time there. So this is the distance mg, multiplied by this distance, which is going to apply the torque of weight, right? And now all you have to do is directly write the equation of angular frequency, right? Root over mgr divided by 5 by 4 mg square, mr square. Then just cancel them, put the values there. That is going to give you the value of omega. And ultimately what you have to do, you have to find out time period, which is 2 pi by omega. So simplify that, put it here, again simplify, you will reach at the value of beta. Please note, g value has been given to you as acceleration due to gravity. If no value was given in the question, I will take it as 9.81, but it is a possibility that somewhere in the question, at some corner, question would have written something like this. So then its value is going to be used as 10, right? So just put the values, then again put the value in 2 pi by omega. Simplify, you will get an expression, and comparing that expression, this expression you have got, and if you compare this expression with this expression, so beta value is equal to root 5 multiplied by root 2, which is equal to 2.659. Okay? If I have to rate this question, definitely for sure I will rate this question as 2, not more than 2. It does not deserve to be rated more than 2, because these types of many questions, more difficult, well more difficult question than this, we all have solved and discussed a lot of times. Have a look at this question from industrial engineering. You have been given different activities, the time duration of those activities, and the precedence relationship of these activities. Precedence relationship means which activity precedes which other activity. You have to find out LFT, latest finish time, of activity number G. Again, this question requires two skills. First skill is drawing the critical network diagram, which for this case I think it's very simple here. And secondly, you have to plot the times and see that which is the latest finish time for activity G. So this is the critical path, critical network diagram for this question. For the sake of representation, I have shown so many details here, but frankly speaking, this question can be solved even without showing all these details, right? Firstly, have a look at the critical path. If we start from here, this is 2, this is 6, this is 3, this is 8. Obviously, this is longer, so we are going to put 8 here. Then to reach from here to here, 10, so 18 directly. If you want to reach from here to here, it is 5 plus 4, 9, plus 3, which is 12, lesser than that. So this remains our critical path currently, right? And 18 is the maximum time. If you go by this way, then 2 plus 3, 5, plus 8 is going to be 13, right? So 13 is the path if you choose this one. Again, not the highest value. So this remains the critical path, and 18 remains the critical duration, entire duration for this. Now, you need to find out activity G, latest finish time, by how much delay you can do in activity G to finish the activity G, correct? If you see, it is ending here at 18, and this activity needs to have 8 units of time. So if you want to get activity G done as late as possible, the time will contract for J, because when G completes, J start. If G starts as late as possible, J has to do the work in 8 only. It requires minimum 8. It cannot do in 7, right? So we want to know that how much is the latest finish time for G, for which this needs to be done in the last hour, till the last hour, right? So at t is equal to 18, it should also get completed. Means it should be starting at t is equal to 10. Means this latest, late to late, it has to finish by t is equal to 10. Using that concept, t is equal to 10 is your answer. Otherwise, using the table and all, you can obviously come back and this gives you the answer 10. So rather than just going by the method, I also thought of explaining you once again the reason for it, right? So 10 is the answer for this question. Have a look at this question, and I think the language of this question may surprise or may seem strange to some of you. 1 mm thick cylinder tube, 100 mm diameter, is orthogonally turned. So we are doing turning of a hollow cylinder clearly, because thickness is given for cylinder, right? So it is hollow definitely, and it is 100 mm of diameter. it is turned in such a way that entire wall thickness of the tube, entire thickness is cut in single pass. What it means that effectively entire thickness we are machining. Basically this is written or represented if the language of the question is correct. Given the language of the question is correct, it's memory based question. So this turning actually is not reducing the diameter because it's just removing the entire thickness. So rather it is reducing the length, because turning is performed, this is the tool, turning is performed in such a way that in one pass, in this thickness, the radial pass, let's consider this is the radial pass, entire thickness it is getting machined. So what is left? It does not have any material at the core, it is the hollow cylinder. So entire thickness is being machined means effectively material has absolutely removed. Some of the material will get absolutely removed. So it is effectively reducing the length. It has been given axial feed also. No? So this is what the process is doing here. That's why I said language may look a little bit strange to you. The speed of the the speed of the tool is 1 meter per minute. Let's say this is the speed in the axial direction. Again, memory based question, lack of data. So I think this is the axial speed. Okay, axial is written here. Great. My mistake. So the axial speed of the tool is 1 meter per minute. Cutting energy of the tube material is given 6 joule per mm cube. How much is the power required? So power requirement directly relates with the cutting energy. Power requirement generally is going to be in watt, joule per second, right? Joule per second, which is nothing but joule per mm cube. Joule per mm cube, specific energy requirement multiplied by the MRR, material removal rate. The very standard expression, right, that we use. Power is equal to specific cutting requirement multiplied by MRR. This you require, this you have been given. You only need to find out the MRR, and MRR for this case is equal to how much? This area multiplied by the cutting velocity, right? That is MRR, cross section rather, multiplied by cutting velocity. That is what we have done here. Cross section area of cylinder is pi dt. D is 100, T is 1 mm, right? So 100 pi directly. Feed is known to us. Feed is what our speed is, right? Feed and axial speed means the same. So when you multiply them together, this and this, you get the MRR. And when you multiply the MRR with the specific cutting requirement, you get the power. So basically you have to multiply cross-section area with the feed with the specific energy or cutting energy requirement. Multiply all of them. This is what you have got as the answer. If question asked you this to answer in kilowatt, this is the answer. If in watt, then obviously I think that will be very lengthy. Question would have asked you actually in kilowatt only. Have a look at this question from CNC machine MP manufacturing. Again, a question which using common sense can be solved in 2 steps. But if you like to remember formulae, then you might struggle a little bit. A CNC work table is driven in a linear direction by a lead screw connected directly to stepper motor. Just like all the cases we have covered. Pitch of the lead screw is 5. So in one rotation, the lead screw moves by 5, work table also moves by 5 mm. Stepper motor completes one full rotation upon running 600 pulses. So after 600 pulses, stepper motor rotates once and lead screw moves by how much? 5 mm lead, right? Once rotation is equal to lead motion of 5 mm means work table motion of 5 mm as well. Then it says if the work table speed is 5 meter per minute and there is no missed pulse, then the pulse rate being received by stepper motor is how much? Look, this is the place from which you are giving the pulse. This is your stepper motor. This is your lead screw on which work table is there. Okay. As you can see that pitch is 5 mm. So for one rotation of lead screw or one rotation of stepper motor, this moves by 5 mm. In 600 pulses, it does one rotation. In 600 pulses, it moves, the machine moves, the work table moves and the lead screw moves by 5 mm in 600 pulses. Okay. So in one pulse, how much it will move? I am interested in knowing it for one pulse. Why? Because I have to tell the pulse rate at which it is being sent. So in one pulse, it will move 5 by 600 mm, right? What is the speed? Speed is 5000 mm per 60 seconds, means per minute, correct? So I want to know, listen to me carefully, that one pulse, how much time it takes for the next pulse to come. The time it takes is this, how much distance is traveled. How much time it will take in traveling this distance is the same time that it will take for the next pulse to come, because one pulse is moving it by this much distance. Now I want to just convert this length to time, this distance to time, means this table moves by 5 by 600 mm in how much time, that I want to know. That will tell me after how much time next pulse will be coming. That's what you have to find out, frequency of pulse, right? If this is the speed of the table, means 500 mm, to move 500 mm, it takes 60 seconds. So to 1 mm, to move 1 mm, how much time it will take? 60 by 500 seconds. And to move by this distance, 5 by 600 mm, how much seconds it will take? This much second. And just simplify it, this will be 10, this will be 1000. So 10 raised to power 4 second is the time that it will take for the next pulse to come. Question is asking you frequency, right? Pulse rate. At what rate pulse are coming? The frequency of them. You can see the units also. Hertz. Hertz is the unit of frequency. And that is nothing but the reciprocal of time per pulse or time per cycle. Basic knowledge, frequency is the opposite of time. Correct? So here frequency is the reciprocal of this 10 raised to power 4 hertz, which is 10 kilohertz. That's it. D is the correct option for this question. Again, one of those questions where if you have mugged up the formula and think you will be able to solve all the question, that's not how it works. If you have understood the process, what is going on in the process, and you apply your knowledge, your concepts, what I have told you, all such questions can be solved easily. So on the basis of difficulty score, I will rate this question as 2 to 3, somewhere between 2 to 3. For the sake of simplicity, let's keep it 3.